Okay. All right, next. Sometimes, okay, you guys remember yesterday we talked about hybridization? We said for carbon, when you get to the 2s layer and the 2p layer, they actually blend, and they actually are sp3s. There's no difference between the s and the p's. They all may end up being the same. This ends up being the 4 directions then. So these would be considered sp3 hybridizations. Okay? What about 5 sticks? What about 5 sticks? If you had 5 sticks, how could you angle them to get them as far away from each other as possible? That's pretty close. That's pretty close. Now, this one is a little weird, but let you guys try it a little bit. See if you can figure out how do you place 5 as far away from each other as possible. Well, now the legs you got actually could be spread out farther. Okay? And so for this one, they're going to do something that is a little bit different. Okay? For this one, it turns out they don't actually make all the same angle. Instead, you know these 3 guys we had the legs coming out? Take them out and put them in square again. So they're like the 120s. And then the other 2 sticks end up being exactly top and bottom. Okay? So for this one, we actually have 2 different angles. Between these guys, they're the 120s. Between any of these, it's a 90. I really don't know why it doesn't do all 5 the same, but it doesn't seem to. When they do experiments, they seem to create this shape. So you got the 120s around the barrel of the marshmallow, and then exactly top and bottom for the other. Okay? Does that make sense? Okay? Now, guys, notice this. When I had just 2 bonding sites, 2 electron domains, you guys remember what the angle was between them? 180. When I had 3 bonding sites, what is true about the angle between them?
120.
120. What's happening to the size of the angle?
It's shrinking.
They're getting down. What about when I had 4? Remember what I said the number was for 4? 109.5. Okay? Now for this one, what we've got is some are 90s, some are 120s. Okay? Alright. We got one last shape. One last shape. The last shape is 6. If you had 6, how could you put 6 toothpicks in so they're as far from each other as possible?
Like this?
This way.
Yep. This one is a little bit more intuitive. Here they're all 90s. You got the 4 corners around the barrel, okay, and then you got top and bottom, okay? And so for the last one, if you had to have 6 bonding sites,
There we go.
okay, that's what you'd end up with, okay?
I did it. Should we still eat the marshmallows?
I would not, because they've been on the tables and stuff, and there's chemicals.
I don't care, I'm still eating it.
Okay? Alright. Yep. Okay. Alright, now, guys. Okay. Okay, guys, I'm going to recommend that you do not eat the marshmallows because they've been on your tabletops. And what else has been on the tabletops? All kinds of chemicals.
I didn't touch the tabletop.
Okay, all kinds of chemicals. So you should not eat the marshmallows. You should throw it away. Okay?
Can they eat the marshmallows?
And that's how you do a diatomic map. That's how you do a valence shell electron pair proposal model. Bye!